right, folks, it's back in action here. In this video, we're going to look at two major topics. We're going to look at how to prove, don't worry, we're not going to write proofs, triangles are similar, and then we're also going to look at some special relationships that happen when we have parallel lines and transversals. So jumping in up here at the top, let's do a quick review on how we did our proofs for congruent triangles. We had several patterns that we did in the first semester, shortcuts, and those were side, angle, side, 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 angle, angle, side, angle, side, angle, and then we had that special one called hypotenuse leg. Now, when we want to prove triangles are similar, our patterns are going to be similar, all puns intended there for you guys. Our patterns are going to be similar, but a little bit different. So we're still going to have another side, angle, side, but we're going to add a new symbol, this little tilde, this little squiggle that is going to stand for our similarity. The major difference between a side angle side congruence and side angle side similarity is that instead of the corresponding sides for the two triangles being congruent, our corresponding sides will be proportional. We're also going to have a side, side, side similarity. Again, instead of congruence, we're going to look for the sides to be proportional. And then we'll have angle, angle similarity. That little tilde is going to be extremely important when you are writing your reasons. Now, let's jump into some examples. So I've got two triangles here, and I want to understand if these triangles are similar, and I want to prove them, meaning I'm going to need to show some amount of work to explain my understanding, even though we're not going to write out proofs. When I look at these, I see that I don't know anything about the angles. So angle, angle similarity is not going to be an option. Side, angle, side is not going to be an option. But I do know all three sides in each triangle, so side, side, side similarity would be a good place to try. So what I'm going to do is I'm going to match up my sides. So I'm going to take the smallest side in the first triangle, I'm going to find the smallest side in the second triangle, and I'm going to write those as a little ratio, meaning a fraction. Then I'm going to match up the medium-sized ones. So a 9.6 is going to match up with the 24. Write that as a ratio in the same order. In this case, I'm doing small on top. Then I'm going to do big to big, write that as a ratio, and I get that. Now, I need to know if all these ratios, all these fractions are the same. So the easiest way, if you have a calculator handy, is to type them each into your calculator, and what you'll find is that each of them will give you a 0.4, which means all the corresponding sides are proportional, so my triangles are similar. Remember, our little tilde means similar. So triangle KJH is going to start at K. That's going to be between my blue and my black ones, my small and my medium. So my next triangle will start at N. KJ goes along the small, so I'm going to go along the small. So my second triangle name will be triangle NML, and that's going to be by side, side, side similarity. Then I can answer this question, angle J will be congruent, and I can either match it up from my picture or I can match it up from my similarity statement, but angle J will be congruent to angle M because in similar figures, corresponding angles are congruent. Let's look at another one. I've got two triangles here. This time I don't know all three sides, so side, side, side similarity won't be a choice. I only know one angle, so angle, angle isn't going to be a choice. But I do know these two sides. So let's look and see if we can do side, angle, side similarity. We can see that the included angles are congruent, so that takes care of the A. Now I want to see if the sides are proportional. So again, I'm going to match them up. The smaller side in my first triangle compared to the smaller side in my second triangle, I'm going to write that as a nice ratio, 22.5 over 9. You could have written it small over big. That part doesn't matter. Then the 25 over the 10. We do need to maintain that same proper order, though. Now, I want to understand if these are the same. I can reduce or I could cross multiply, but either way, I am going to find that when I reduce each of these, I'm going to get a nice 2.5 on both of them. So yes, my sides are proportional. So my triangle, ABC, A, B, A is at the end of the short side. So I'm going to start with E, goes along the side that doesn't know anything. So my second triangle, triangle ABC, will be similar to triangle EFD. And these are going to be similar by side angle side similarity. The last thing that we could do is we can actually now find a measure. If we know, for example, that EF is 16, we could find the length of AB because those are corresponding. So I could set up a nice proportion for this. I could match up the two of the sides that I know. I'm going to choose the 10 and the 25 just because they're the cleanest for me. So 10 to 25 is equal to, now I'm going to match up what I'm trying to find, x over 16. You could reduce this left-hand side if you wanted to reduce that each side by 5. That might make your math a little bit easier for you. But we're going to get a 5x equals 32. If we want to write this one as a decimal, we can. I'm going to write this as x equals 6.4. Okay? Let's look at another one. And this one, I have a single figure. I do only have two triangles here, and I don't know anything about any of the sides, which means neither of these are going to be options for me to think about similarity. I do like, especially when I have nested triangles, I like to outline those triangles. So I'm going to outline the two triangles that I have here. And I notice that I'm already given a pair of angles that are congruent, and then when I outline them, I see that I get another angle that's the shared angle right here. So these triangles will be similar by angle-angle similarity. When I write the new triangle name, I can see that my first triangle that I'm starting with is starting with the shared angle and is going to the angle that didn't have any markings in it at all. So my second triangle is also going to start with the shared angle and is now going to go to F. So my second triangle name is triangle AFB. Again, as a reminder, corresponding angles are congruent. So angle C will correspond with F. So angle C is congruent to angle F. Now the next one that we're going to do is we're going to look at another one of these nested triangles. Okay. So I'm going to have this triangle right here. This is a very, very commonly used problem, so you'll want to get very familiar with this picture. There are many ways we can get our angles to be congruent. We cannot use side angle side or side 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 because I only know two sides in this triangle, but in the big blue triangle, I only know the one. I do not know this length, so neither of these options are going to work for me. But I do see that they have a shared angle, the lines are parallel, so these corresponding angles are congruent, or these corresponding angles are congruent. Either way, these triangles are similar by angle-angle similarity. So my second triangle name, ABD, is congruent to ACD. Triangle ACD. Now, if I want to solve for x, I'm going to match up the parts that I know. So I can see that the 5 corresponds with the x. That's what I'm trying to find. The other side that I know in the small triangle is the 3, and it corresponds with this entire side in the big triangle, which is actually a 10. So 5 over x equals 3 over 10. So I'm going to get a 3x equals 50, and if we want to write this as an approximated decimal, we can, and write this as 16.7. Okay, that's all we have for the similar triangles. Now let's look and see at what happens with some special cases when we have parallel lines. So our theorem here in section 7.4 is two lines are parallel if and only if their transversals are divided proportionally. That if and only if is something from last semester. So the first one that we're going to look at here is I've given you some congruent angles. So we're going to mark these congruent angles, which would mean we should be able to remember that if these various angles are congruent, then all of our lines are in fact parallel. If our lines are parallel, then this theorem tells us that these transversals have been divided proportionally. So the ratio of 8 to 12 will be the same as the ratio of 9 to x. So we're going to get a very quick and very easy little proportion to solve there. 8 over 12 equals 9 over x. If we cross multiply that problem there, that 8 over 12, 9 over x, if you want, you could even reduce this. Sometimes I think that's handier if you don't have a calculator. Okay, if we cross multiply this, we're going to 2x equals a 27. So x is going to equal a 13.5. On the next problem, it wants us to determine if the lines are parallel. So that goes back to our if and only if. If they're parallel, we're going to think of this the other direction. Then these ratios, these transversals, should be divided proportionally. 4 over x, or 4 over 6 I meant to say, should be equal to 7 over 10. Now, if we cross multiply this is our other strategy for checking, we would see that 40 is clearly not equal to 42, so no, these lines are not parallel. The next one that we're going to do, notice this picture looks very similar to the picture that right above it. Notice that all of my markings are on the parallel, are on the transversals. They're not on these parallel lines, okay? If the lines are parallel, the parts, the sides are proportional. So 3 over 7 is equal to 5 over x. The transversals are divided proportionally. Now we can cross multiply and get 3x equals 35, or x is approximately, since it's not a terminating decimal, 11.7. I do want you to take some time to do some comparison of these two examples right here and make sure that you can easily recognize the difference in those markings. The last one we're going to do is, again, we've got some parallel lines. We've got markings on the transversals, so they have been divided proportionally. I can see that the 5 is going to correspond with the 12. And I can see that I'm given this entire transversal of a 3x plus 1. And I want to match that up to the entire transversal over here of an x plus 12. Now I'm going to cross multiply these. So I'm going to get a 5x plus a 60 and a 36x plus a 12. Solving this equation, I'm going to get a 31x. Subtracting my 12 from each side, I'm going to get a 48. It's not going to turn out to be a nice number. I can round this one to an approximated decimal as well. This one, I'll take it to hundredths. Remember to always read the directions on how it asks you to round your answers. Okay, when you come in class, we'll do some more practice with this and definitely take some time, again, to compare these two examples here so that you could easily recognize the differences between them.